In this video, we're going to go over the homework solutions to the area problems y'all were given in class. For number 1, you are given a function and you're given the endpoints, really. That's what you're given here in the particular problem. You've got these two, those are your endpoints, and so you're trying to find the closest approximation for the area. So we will integrate from negative 2/3 to positive 2/3, and our function, now this is a calculator problem, and our calculators, the inspires, can be kind of funky when you put these in. You need to make sure, and I'm sure there'll be a couple of parentheses that come up, but you need to make sure this exponent 4 is on the outside. You can't leave it on the inside like it's written. The calculators will not work with that. You have to move out the exponent. And once you type all that in your calculator, and to make sure your calculator is set in radians, so do make sure that happens. And you should have something that comes up once you type all that in. Let's see, 0.9190498. So the closest integer approximation to that would be 1. Our next problem, it's important for us to understand the whole idea of integration. Now we're given the graph of barrels per hour, and so really we've got a rate here. But instead of being asked about the flow of oil into the barrels, I'm asked about the total number of barrels. So I need to do something to remove that rate. And a lot of times if you integrate, you remove a rate. So integrate removes the rate. And that's good for us to remember. Also, if we're talking about an integral, we're talking about a bounded area. So really what this amounts to is for us to try to approximate the area. So notice we do have a lot of rectangles under here, and we might do an overestimate on that first rectangle, but that should be okay. Now keep in mind that the width is 6, length is 100, so the area is 600, and that's for all of these little rectangles here. So notice we're already at 2400, and that is a little bit more because we see this little area here and here, but we still have to account for this area up here, which looks like it's going to be another about 600. So it's safe to say a good approximation for that would be answer choice D. All right, for number 3, again, we're looking for our bounded area, and it's good to do a quick sketch, and we're looking from 0 to 2 of our bounded area. So let's do a quick sketch here. We have a parabola, and we're cutting that with a line that has a negative slope. So we're going to pretend that went through 0, 0 there. And so when we do our line, negative x is going to cut somewhere through here. Okay, so notice that from 0 to 2, we've got this little area over here. And we're not sure, well, which one's on top, which one's on bottom. And if you're not sure with that, do note that this is always positive. This one's always, or most of the time it's negative. It could become positive. So when we're setting up our integral and we're moving from 0 to 2, we need to figure out, well, which part's going to be on top here. So what we need to do is, a good idea would be just to pick a number between 0 and 1 and plug in. Or 0 and 2, which is 1, and plug in. And if we do, we have our parabola being greater. So we're going to have our top minus our bottom. So minus the negative x, so that's positive x dx. And when we integrate this, we're going to have x cubed over 3 plus x squared over 2, and we're integrating this from 0 to 2. And so let's see, keep going here. So we're going to get 8 over 3 plus, and let's see, 4 over 2, so 2. So there's what we're going to get, minus our bottom endpoint, which is just going to generate a 0. Yay for 0 endpoints. So let's see, we're going to get 8 over 3 plus 2. So let's see, 8 over 3 plus, and let's see, that's going to be 6 over 3. So most days that gives us 14 over 3. So our answer choice is D. Okay, our next problem is a calculator problem. And we would need to find our point of intersection between the graphs. And if we sketch this out, we know what cosine looks like. It starts up here. That's something like that. We know what the graph of y equals x looks like. And we're just focusing in the first quadrant. So we need to find our point of intersection because that is going to be an endpoint. And so if we use our calculators and we find that point of intersection, that's going to be the value 0.739085. All right, and so now we're ready to integrate. We are moving from 0 to our point of intersection, 39085. And we need to integrate our top function, which is our cosine x, minus the bottom function. And so once you type that in your calculators, it looks like you should get answer choice C. And again, make sure your calculator is set to radians. All right, number 5. Number 5 can seem tricky, but in the end, it's not too terribly bad. The first part of this, you're told that if I integrate my function from 1 to 3, I get 2.3. So I know from 1 to 3, this bounded area right here has a value of 2.3. All right, now the next question we're asked is, well, what does f at 3 minus f at 0 equal? Well, let's think about this for a minute. F at 3 minus f at 0, that's the original function, isn't it? Well, if we think about this, that's really asking us, what is the bounded area from 0 to 3 of our function? So that's what this is asking us, because if we integrate that, we're going to get f at 3 minus f at 0. And so really all this amounts to is adding this area and this area to what we already know. Well, what is that area? Well, we've got 1 times 2, so that area is 2. So 2 plus 2.3, that's going to give us 4.3, which is answer choice D. Okay, so another great area problem. Here we have a parabola, x squared plus 1. So our parabola has been moved up 1. So it looks something like this. And then we have a line y equals 5. It's going to cut across this. So we're looking at this bounded area here. So we need, when we integrate, we already see that my line is on top. So we're going to have 5 minus x squared plus 1 dx. But I need my endpoints. So what we need to do is set our two functions equal to each other and solve. So it looks like we're going to get x squared minus 4 equals 0. So our 2 points would be plus or minus 2. So I'm integrating from negative 2 to positive 2. And so let's distribute our negatives. So we have negative 2 to 2 of 5 minus x squared minus 1 dx. And again, I would continue collecting my terms to make it a little bit easier. So we're going to integrate from negative 2 to 2 of 4 minus x squared dx. And so we end up with, if we need to integrate, so we have x cubed over 3. And we're looking at this from negative 2 to 2. And now we're ready to evaluate. So when we evaluate here, we're going to get 8 minus 8/3. So there's the top endpoint minus, and let's plug in the bottom endpoint, so negative 8. And then we're going to have minus, but then that's going to be negative 8/3, so positive 8/3. And so we're going to end up with 16 minus, let's see, 16 minus, and we're going to have negative 16/3. If I can get my pen to write, that'd be great. That does tend to make things a bit easier. 8 and 8, 16. Woo! All right. So common denominator is 3, so that 16 goes to 48/3 minus 16/3. So most days that gives us 32/3, which is going to be answer choice D. Okay, for this problem, again, we are finding the bounded area. And we can very quickly go through and see a sketch of this. We have our parabola. Yay, I got through 0, 0 this time. And then we have this line going through. And my line doesn't look so great. And so we need to find the area, bounded area. So we need to go ahead and set our two equations equal to each other to solve and see where our endpoints are. And so it looks like our endpoints are going to be 0 and x equals 1. Now we need to also figure out, well, which function is on top here. It kind of looks like the linear one might be, but we don't really want to chance this. So let's see, we're integrating from 0 to 1. If we pick a number between 0 and 1 and plug in, well, let's plug in a half. So if I plug in a half, that's going to become a fourth, and this is still a half. A half is certainly bigger than a fourth. So our top function is x, our bottom function is x squared. All right, and now let's go ahead and integrate that. So we're going to have x squared over 2 minus x cubed over 3, evaluated from 0 to 1. And so that's going to give us 1/2 minus 1/3, which is going to be 1/6. So that's answer choice A. Okay, number 8, again, working through this. Now this time we have the function 1/x minus 1. So we have our rational function that's been moved over, or moved to the right 1. And so we have something that looks like this, and then over here on this other side, something that looks like that. And that's why we have our boundaries of x equals 4 and x equals 3, because if we didn't have these lines here given to us, we wouldn't have any bounds. Right, so we're looking for that bounded region there, that area. So we will integrate from 3 to 4 of 1/x minus 1 dx. And so this is following the pattern when we have the 1/. Remember, if we integrate, let's see, stuff prime over stuff. In other words, what we're integrating, if the numerator is the derivative of the denominator, that always turns into the natural log of the absolute value of stuff every time. So let's check this one out. If I take the derivative of x minus 1, I get 1, which is my numerator. So that tells me when I integrate, it's just going to end up being the natural log of the absolute value of x minus 1. And I do need to evaluate this from 3 to 4. So we're going to sub in here, and so I'm going to have the natural log of 3 minus the natural log of 2. And remember, we can condense logarithms if they're expanded by subtraction. We can condense with division. So that gives us answer choice D. All right, number 9, again, still talking about area here. And it's looking to see, do we understand the concept of the integration with the area, the bounded area? Notice our top function is D, the bottom function is f of x, and we have endpoints from A to B. So looking at our answer choices, the only one that's going to be correct here is going to have to be answer choice B. All right, moving on to number 10, and number 10 can be kind of tricky. We have to be careful because this one is asking for the average value. Every time you see average value, it's 1 over the difference of your endpoints from A to B of your function. And I'm just going to write out the word function there. So we have to be careful with this. Now we need to find our endpoints, and it's talking about just in the first quadrant. So I would go ahead and set my function equal to 0 and find the zeros for it. And when we do that, we factor out an x, and we have 3 minus x. So it looks like my two zeros are 0 and 3. So now we go through here and let's integrate. And we're integrating from 0 to 3 of our function 3x minus x squared. But we are also trying to find in this process the average value of that function. So I need 1 over the difference of my endpoints. So we end up with 1/3 times, this is going to be 3x squared all over 2 minus x cubed all over 3. And I'm evaluating that from 0 to 3. So that's going to give me 1/3 times, well, let's see, we're going to get 27 over 2 and minus 27 over 3, isn't it? All right, and so let's see, goodness, what are we going to get from this? All right, so we will end up with, well, my iPad's wigging out, folks, so sorry. So we have 1/3 times 27 over 2 minus, that's going to be 9, which is really 18 over 2. And so we have 1/3 times 27 minus 18. Looks like we're going to have 9/2. So we end up with 3/2. So we're going to have answer choice C for this one. Okay, for our free response problem, this is a calculator problem, and you'll have to put these graphs into the calculator to find their points of intersection. And when you do, this point of intersection here, which is what you need to find, you're going to have 1.03283. That's going to be your point of intersection. And when you set this up, let's see, the function that's going to be on top is going to be your g of x, and the function on bottom is f of x. And whenever you're finding the sum of these areas, what you need to be able to do is just set up the problem. So the setup of this, and this problem was worth 4 points, so we really need to make sure we can do it. What they need to see as an AP reader is going to be from 0 to your point of intersection, 03283. And you can just write the function's name. You don't have to rewrite the entire function. So you've got g of x minus f of x. And that's for the first part. That's going to take care of r. And then you have plus, and then you're going to go through and set up this again for the sum of s. And so you're going to start off again at that point of intersection, 3283, up to the other endpoint of 2. But this time when you integrate, the functions have changed. So again, we're looking at this area over here. So that's going to be your f of x minus g of x dx. And you can type all of that in your calculators and come up with your final answer. Now the final answer to this was only worth 1 point. The bulk of your points will be in showing the setup of this, which is what I've given you here. Okay, for our next problem, and this was a non-calculator problem, and they're asking you to find the area, and again this was worth 4 points. So let's see if we can set this up. And they were nice, and they gave us our endpoints. So we know we're integrating from 0 to 2. And let's see, we have to remember what our functions look like. Well, x squared is a parabola, so that's probably going to be the bottom function. And cosine always starts up here at 1, and the amplitude of this is 4. So that makes sense. So our top function is going to be cosine. So we have 4 cosine of, and that's really just pi over 4 times x. So there's my top function minus my bottom function, 2x squared minus 6x plus 4. Okay, so there's our setup of the problem. Now let's go ahead and I would separate these and integrate individually. So I'm going to move that 4 to the outside. So I have 4 times the integral from 0 to 2 of cosine of pi over 4x. And then minus, and I'm going to factor out a 2 here, and then I'm going to integrate again from 0 to 2 of x squared minus 3x plus 2. All right, and I forgot my dx's. Oops, needs more crack, folks. All right, so with this one, we can think about a u substitution right quick, and we can do that pretty quick. We say, okay, u is going to be pi over 4x. So du is going to be pi over 4 dx. So I know that I need to make that adjustment here. And so this one would become 4 times, and then I've got to multiply by 4 over pi to cancel out. And I'm still integrating. I don't know what happened to my pi symbol there. God help it. And we're still integrating from 0 to 2. Of cosine of u du. All right, and so now let's see minus, and there's really no adjustments to make over here to this other integral, so we're just going to bring that down. So 2, if my pen would write, 2 times the integral from 0 to 2 of x squared minus 3x plus 2. All right, so now we're ready to really do the integration, and I'm going to move this up to the top here. And so let's go ahead and integrate that. So I'm going to have 16 over pi, and the integral of cosine of u is going to be sine of u, but we also saw that u had another value. U was pi over 4x. And I'm evaluating this from 0 to 2. And then minus. And we'll go ahead here. And whenever I integrate our quadratic, we're going to have 2 times. Crap, I got to put in my 2 times. When we integrate that, that's going to give us x cubed over 3 minus 3x squared over 2. Looks like I'm about to run out of room. Plus 2x. We are evaluating this from the same endpoint, 0 to 2. So let's see what we ended up with here. When we plug in, we still have our 16 over pi times, and if we plug in our 2 here, we're really going to get 2 pi over 4, which is going to just be pi over 2, and sine of pi over 2 is 1, minus, if we plug in 0, sine of 0 is 0. And then minus, and then over here we have 2 times. And remember, once you get all of this plugged in, you can stop. So you have 8/3 minus 4, 12 over 2, plus 4, and then all of that minus 0. So you can stop there, and that should be enough to get you your point. All right, for part A, you're asked to find all the values of x on the open interval from 0 to 8 for which the function has a local minimum. So with a local minimum, that means we are looking for, and we have the graph of f prime. I'm trying to find a place to put A. So here we go. I'm just going to move this up to the top because I'm about out of room. So for this one, sorry folks. So for A, we know that f is going to have, or f has a local or relative min, and at x equals 6. Now, you need to also state why you know that. Because I know that at x equals 6, let's think about what's happening around x equals 6. Well, f prime changes from, and since it's a local min, we have to make sure it changes from a negative value to a positive value. So at x equals 6, f prime changes from a negative to a positive value. And that should be enough. We found the point and we stated why we know that. All right, let's move on to part B. And part B means that you need to find the absolute minimum. So to find your absolute minimum, you do need to set up a chart. And this is where we went through and we set up our x and our f of x. And for an absolute minimum, you have to always check your endpoints. So notice we are including our endpoints, so we have to integrate or find some value from 0 to 8. But then we also have to go back and consider our relative min, which in this case was 6. So we need to go through here, and we already know f at 8 because that was given to us. F at 8 is 4. So that just leaves us with 2 more values that we have to go find. So since we do know f of 8, let's use that when we set up our integrals. So let's go through and let's see if we can find f at 0. So to find f at 0, we need to integrate from 0, what we don't know, to what we do know, which is 8 of f prime. So let me change this. Of f prime of x dx, and they've already told us that that bounded area, if we're going from 0 to 8, we can go through and add up all of our areas, and so that's going to end up equaling 12. But now we also know that this is going to give us f at 8 minus f at 0, which is going to have to be equal to 12, and we know f at 8 is 4. So we have 4 minus f at 0. I don't know if y'all can hear Miss Hamby in the background. She's going to love knowing she's on this. So after we solve that equation, we're going to have f at 0 equals, let's see, subtract 4, change our sign, so negative 8. So here we have negative 8. Now we're going to do the same process, but we're going to integrate from what we don't know to what we do know. So we're going to integrate from, it looks like we need to do from 6 to 8 of f at t dt, or f prime, sorry. I'm on another problem. Let's back it up. F prime at x dx. And so if we add up all of those areas, we see we end up with 7. So we know f at 8 minus f at 6, come on, minus 7, equals 7. But now we do know f at 8 is 4. So we have 4 minus f at 6 equals 7. And so when we work all that out, we end up with negative 3. So over here, I know negative 3 for 6. So now we just pick out what's the smallest value and make our statement about it. So for this one, we see that the absolute min for f at x on the interval, and make sure you have the closed interval from 0 to 8. So the absolute min for f of x on the closed interval from 0 to 8 is, and what was that, is negative 8. And you've answered that one. Okay, that was part B. Now let's see for part C. Let's find some room for part C. Part C is asking us, let me come over here and read it. Part C is asking on what open intervals contained in 0 to 8 is the graph of f both concave down and increasing. So let's think about what's going to happen here. F is concave down. Let's see, we know that when f double prime is less than 0, or when do I know f double prime is less than 0? When f prime is decreasing. So that's pretty cool to make that connections. So we now know we're looking for when f prime is decreasing. So f prime is decreasing, and we need to know when also f is increasing. So gosh, f is concave down when f double prime or f prime is decreasing. Let's see, and then f is increasing. So that's going to be, was it f is increasing? F is increasing when f prime is positive. So to put all this together, we're looking for where f prime is decreasing but is positive. So let's look at our graph. So we're looking for decreasing and positive. So the first interval that I see where that is true is going to be the interval from 0 to, let's see, 0 to 1. And this happens once more that you're decreasing and positive from 3 to 4. All right, I hope this video helps.